We start by a simple model called the linear regression, the supervised learning part. So chapter 3 of our textbook deals with linear regression. This is very simple yet useful algorithm. So the linear regression, let's consider pros and cons of linear regression. This is simple yet useful. Cons is it's too simple. Too simple means true function, so real function f that generate y with irreducible error are never linear, which means the linear regression essentially will have bias error. And this could be huge if your true function f is very wiggly curves. Okay, in that case, linear regression model has some bias error. We cannot remove such error, which comes from your simple structure. Okay. Oh, by the way, linear regression means we want to feed our training data point using some linear function. So what is the linear function? So here is the main assumption of linear regression model. So the assumption is your output y comes from a very simple linear function, beta 0 plus beta 1x plus irreducible error epsilon. Here x is the input predictor and y is the output. So this is input, this is output. And these two values are coefficient or variables. And for the linear regression, each component has name. This is intercept. This is called slope. Okay. So linear regression, very simple. We can define the function using two coefficients or parameters. And here the learning process is finding the two coefficients from training data point. Okay. Then how to find the coefficient. From data. So assume we have n number of training data points. So n pair of x and y. So basically, almost all machine learning process follows these steps. First, define a loss function or error function, objective function. So to name but few, so you can use any name. And then optimize the loss function. The loss function is function of coefficient. So optimize the loss function means finding the coefficient that minimize the loss function. So more precisely, I'll give you an example. One very popular loss function is RSS, full regression task. residual sum of squares. So what is residual? Here residual is also called error. This is the difference, basically just the difference between the true output label or output value yi and the estimated output value y hat I. So here y hat I is equal to beta hat 0 plus beta hat 1 x I. Or let's say just beta 0 and beta 1 xi. Right. Then the RSS value is function of beta 0 and beta 1. And RSS function, the definition of RSS function is residual sum of squares. So we have to sum up over entire training data point. This is sum from index 1 to the last index n yi minus beta 0 minus beta 1 xi square. This is function of beta 0 and beta 1. Okay. So we have loss function. Then we can find coefficient. We just need to solve this optimization problem. And beta 0 hat and beta 1 hat, the result will be just argument that minimized the RSS function. That's it. You learn everything for linear regression.